Hello and welcome. So Harry Seiders, one of my all-time favorite case authors, has just published a case called 1001 Binary Solo. I feel like I'm missing a reference or a joke or a wordplay or something, but I don't know what that means. Anyway, uh, it is available. I'll put the link in the video description. He's selling it for $5 because it's not part of the MEWC or anything like that. And I'm going to give it a go. So let's go. Download the case. I'm going to come over here. And I have a folder ready for it, just like usual. Let's open it up. It looks like it's got levels, but not bonuses. Please refer to the instructions tab to read and understand how the Hamming code. Oh, Hamming code, I vaguely remember that. Hamming code is a way of error checking for a string of ones and zeros by inserting check digits into the data. Check digit will always make sure that the sum of the digits it is checking is always even. No, I'm thinking of the Hamming distance, not the Hamming code. Okay. 16 numbers of the code. Helpful in explaining how it works, please note that the first digit is considered the 0 spot. Okay. Each 16-digit string will have 5 check digits. Spot 0 is to check the other 15 as created last. Spot 1 is to check all of those. Spot 2 is to check that, that, and that. Okay. You're in a 15-bit code, but you're missing the initial digit spot 0. Please indicate if the first digit... Okay, so hang on. Wait. Okay, sorry. Check digits will always make sure that the sum of the digits is checking is even. Got it. So in other words, these are odd. So with that it becomes even. Yes. These are odd. So with that it becomes even. Yes. This sums to an odd number, so with that it becomes even. Yes. And this sums to an odd number, so with that it becomes even. Yes. But then this one, these sum to an even number. So why is that one? Sum of the digits it is checking is always even. Or is this just, I guess that's just summing the whole thing? Right, sorry, yes, to check all the other 15. Got it. Now I get it. Okay. So please indicate if the first digit should be a 0 or a 1. So I'm just going to import my thingies, my lambdas, and then do letters, this times 1, and then sum of that. And I think I just want mod of that by 2. Quick check there. I think that's okay. I guess I'll put in the code so I can find out if I'm getting the answers right. Okay, level 2, there are no errors in the code. Take the code, ignoring the error check digits, and convert it from a binary to a base 10 number. Okay, so hang on. Let's just do sequence 4, 4. Then I'm interested in getting rid of 1, 2, 3, 5, and 9. Okay, so what do I want? I guess I want to X out that, and that. And then I want to say to call ifs this equals blank, then this. 3. So those are the positions I want. And then take the code, convert from a binary. Yes, I think. Then I want this will be the last digit, so that's a 1, and then this times 2, and on up. Okay, so I think I want to say mid this by this lock 1, and then I want to say this times this, and that doesn't give 461. Okay, fine. Then that works. Oops, missed a bit. Times, and then sum. lot of zeros here. Why so many zeros? Because I didn't lock. Oh, locking, you'll kill me one of these days. Okay. Level 3, turn the base 10 number into a binary code with the correct check digits. Okay. So, check digits I'm interested in. Here we are. So let's do equals 2-row text split. I don't need a 2-row actually, so let's do the text split right. By comma. So that is spot 1. And that goes in position 2. I'm not doing 0 based. Sorry, Harry. That times 1. Then spot in number 3 will be on all of these. Okay. And then this one. Okay. It looks very similar, but okay. Fine. And that is the one in position 5 for me. Just double check. Yes, 2, 3, 5, and 9. Yes. Okay, and then this one. Yeah, these. Okay. Oh shoot, but that's not the positions that I actually want because so I want a sequence of 11. I actually want to XLOOKUP this in here, lock returning from here, lock. Nope, didn't like that. What? That's confusing. Oh, yeah, because I am switching bases all the bloody time. Okay, fine. So we'll XLOOKUP that in here, lock returning from here, lock. Okay, so these are the digits in the original thing before we buffer it out. Oh my gosh, this is complicated. Okay. So then we need to, I guess, copy that for all the others and then just put in the numbers again. Not feeling like I'm doing this the most efficient way, but I think it's a solid setup. Might have been more efficient to just lay it out in a grid, actually, but I don't know, whatever, too late. Okay, so so my extra checks are going to be 1, 2, 3, 5, and 9. 1, 2, 3, 5, and 9. So here I'm going to XLOOKUP 9 in here, lock returning from here, lock. That's going to give me those positions. Then I want to mid this. Oh, wait, what? Oh, god damn it. Turn the base 10 number into a binary code. Okay, so sorry. First I need to, will deck to bin work here? Not sure. I need 11 digits. Nope, doesn't like that. Oy, frustrating. Okay. So how are we going to do it? Let's mod this by 2 to the power of sequence. 11 rows starting at 10, steps in -1. Yes. This is my sequence of powers. Then I want to mod this by, I guess, 2 times P. And then I want to divide it by p. And then I want to take the int of that, I think. And let's just see. Give me my p here again. Sum of this times this. Did that work? Yes, it did. Okay. Happy days. So then we'll concat. Okay. So one more time. Now I want mid of this by all of these. 1. Give me a bunch of digits. I want to sum minus minus of all of those. That gives me that, and then I want to mod that by 2. So that did that. Then I'm going to lock that. No, it's all right. Lock that, and the rest is fine. So those are those digits, and then I want to mod some letters of this times 1 and all of these by 2. I think that's it. Then I just need these. So then this will be mid of this by this 1 times 1. And then finally, I think I want to concat sort by, sort all of these by all of these. Is this going to be right? I feel kind of amazed if it's right, because, yeah, no, it actually worked. Whee! Okay. Well, everything's wrong now. Why? Probably because I didn't lock some stupid thing again. Yes, it is for exactly that reason. Lock. Okay. Low confidence in those, but okay. Fine. There is one error in each code. Find and fix the error and determine what the base 10 number written in binary code should be. Answer written in base 10. Hint, it is possible that error is with the check digit itself. Yikes! This is tough. Code is now 3 16-bit put together. Determine the 3 numbers and add them together. Each portion of the string may have an error in it. Oh my god. And that's the end of the case. Okay. Alright. So the instructions are a little terse here, but let's think about this. How would we know? I guess there is, let's see. Yeah, so we need to figure out if each thing what has an error, and then I guess take the intersection of those in some way. Oh boy, it's complicated. Okay. So here's the, so what is this? Is a 16-digit code? Yes. Okay. Okay. So I guess I want to check which checks check out. That's what I want to do. Oh, now I should have kept the original versions of these as well, but never mind. I'll reverse them. So let's look up this in here, block returning from here to get back to the original order. I'm just going to color these differently. Let's make that one orange and this one green. I guess we're making these blue. Why not? Okay. So for each of my checks, I want to XLOOKUP this, lock in this, lock returning from this, lock. Then I want to mid this, lock by all of that by 1. And I want to know if the sum of those, no, hang on. Yes, I guess I also want the number itself. You didn't like that? Oh, because I put the closing bracket in the wrong place. Okay, so now I've got 8 digits, which is what I want. Sum minus minus all of that, and mod that by 2. Okay, so there's an error in position in check 5 and in check 9, and then we just need to check the overall, which will be mod sum minus minus letters of this by 2. Okay, so there's an error in the overall and in 5 and in 9. So what does that mean? One in 5 meaning 4, and I mean here, so there's the bottom, but there's not an error in that or that, which means it's here. Okay, so I guess I need a table of which things depend on which. So I guess here I can just say minus minus x match this. Yeah, let's do it. X lookup this in this lock returning from this lock. Then we're going to do X match this lock against that. And we're going to say minus minus is number. And it stopped working. Sorry, thought I had locked this, but apparently I didn't. Try again. Okay, and then yeah, and then the last one applies to everything. So let's make it we're going to sequence 16 1 1. Sorry, no 1 0. So then the question is, if I take unique of these, duplicates are found. Huh? Dang it! What? The whole point is that they should be unique. So what's duplicated? Oh, the check digits. Fine. I think that's fine. Oh, actually, no. You know what? I should. Yes. Okay. So against hstack, this itself with all of that. Boom. Now we have unique codes. Okay. So now, yeah. So I think I can then say x match, x lookup. No, x match is fine. X match concat of all of these against this. That should tell me where the error is. So the error is in position 13. So then I should be able to say if sequence 16 equals this, then I guess let's start with let digits be letters of this. Then I want 1 minus digits, otherwise I want digits. No, you didn't like that. What? Oh, yeah, because you're missing the underscore. That's better. And then concat. And then I need my conversion, which I should have made a lambda when I first did it, but I didn't, so I'll do it now. Okay, so it's going to be lambda of CD for code. These need to be locked. And I'll use my away robot. Slouching. Stop slouching. So we're going to save lambda, and we'll call it code to deck. And then I have one down here. This one? Yes, that is decked code. So we'll say lambda num. You didn't like that? Well, fine. 75. Make it back to there. Sorry, what the heck did I call my first one? I called it code to deck, so I guess I'll call this one deck to code. Save lambda, deck to code. Okay. So equals code to deck of that. Hey, it worked. It's a beautiful miracle. Okay, so now kind of want to be able to make this all into one lambda. Can I do that? Tricky, tricky, tricky. So you know what? I can actually do this, I think, with a little more creativity. So let's h-stack this with this, locking both. Need to be able to make it a little more array friendly for this to work, but I think I can do that. So then we'll say mid of number by all of this stuff by 1. And then we'll do by row, yes, of minus minus all that stuff, sum. And that'll give me, oh yeah, sorry, mod 2. And that'll give me 0, 0, 1, 1, just like that. Perfect. And then just take this, so we'll do concat of that with this. Could probably just do the mod ones, but never mind. That's working. So then we'll let, let's say fails be that. Then we'll call it break, can be xmatch fails against list of fails, lock. And then, oh yeah, sorry, got to start with code, cd. That goes in there. Yes, and in here. Okay. And then we want to do whatever the wrap-up bit is. I'll get to that in a second. So we'll call it break. So digits, and then the answer. Okay. So digits is letters of code, and then we're gonna got if sequence 16 equals the break. Then one is digits. No, don't want to accept your corrections. What's wrong? One extra bracket. Okay. Oh, and then finally, code to deck of all that nonsense. Hooray! Okay. So now, hopefully that cracks all those, but then I think that'll make level 5 come out as well. So 3 16-digit numbers put together. So I think I just need, well, I should really, let's make this a lambda, cd, get rid of all that, and then just give it this code. Okay, and then let's save lambda. Error fix. So then I think, well, let's spread it out. So we'll say mid of this. Start num will be 1, 17, and 33. Number of characters will be 16. That gives me my 3 numbers. Make it a little easier to read if I do it that way. And then I don't think I can directly apply error fix to this because I don't think it'll work over an array. Nope, but I can map it. So we'll map all of this by error fix. Sum them up. Oh, look at that! Wrap with sum. Uh-oh. No, it's broken. Why is it broken? Oh, that's an interesting question. Glad you asked. Let's go look. So let's get rid of the sum. What the heck is going on here? Okay, so get rid of the map. Oh, hang on, wait. May have an error in it. Ah ha 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 ha. So I think what we're saying is that this one does not have an error in it. Possibly. Sneaky, sneaky. Okay, so let's grab all of this, bring it down here. Then I just want to get back breaks. So sorry, where's my for this code? Just give me all that output, which I should have done in the first place, because that's good. Let have it, and then no, not breaks. I want fails. I think I called it. Yes, fails. Ah, yes, there's nothing. Okay, so then slight tweak to the code. So go back to error fix, edit lambda, and oh, look at all that space. So spacey. That's fails. No, further down, further down, further down. Okay, here we are. So we just say if error, if fails is not in the list, that means that none of them has failed, which means you can just say 0, and it'll work absolutely fine. Save lambda, and now we've got no NAs, and I think we're good. Well, let's just see. So if I do error fix on this, it should give me the exact same as just code to deck of that, and it does. And now we have something. So now, moment of truth, let's take all these answers. So I haven't put anything in the platform since level 1. All right, well, this all comes out right first time. I'll be very happy with myself. Let's submit. Am I? Yes, let's go for it. Ah, dang. Okay, let's see, review answers. What did I get wrong? I got section 3 wrong. Let's have a look at that. Level 3, okay. So, turn the base 10 number into a binary code with the correct check digits. Okay, yes, this is somewhat separate from the rest. So first, I converted it into binary digit and binary string, and those are all length 11, so that's fine. I will look at the actual answers in a minute, but I'm hoping to figure out what I did wrong without that. So let's see, so this is the sum of all the 11 in there plus these 4, that makes sense. But this, yeah, no, that's right. So that's giving me the other 7 digits that's checking, and then mod that 2 is going to make that. Yeah, okay, that seems right. Did I thought I matched the answer here. True. Okay. Harry did say that the FlexiQuiz is not, it doesn't do partial marks. So let's just take this, put it here. Let's go text split of this by semicolon. And let's see. I don't know, looks like not a single one of them matches. There must be something else not locked in that case if I'm matching the answer exactly right. That is locked. That is locked. That is locked. That is locked. This is locked. All right, well, anyway, I don't know. I'm not going to make you watch me debug that because that's not super exciting. There it is, for goodness sake. Okay, just as I said, I'm not going to make you watch me. I'm going to make you watch me because I just found it. I'm sorting by this, but I didn't lock it, so I'm sorting by random digits in every other place. So now, oh, interesting. The last one is still, did I not copy down all the way? That's funny. I've got one of them wrong? Really? That looks the same to me. Right. Confused. That definitely looks the same to me. What's the difference here? Huh? Super confused by that one. Anyway, doesn't matter. I think I'm now basically working. So puzzled. All right, I can't help myself. I'm going to try and check this. So let's do letters of this. end of this. Oh, one of them is long. Ah, right. Sorry, I bet the thing that I copied from here has a space at the end. There we go. Okay. So, got to be a little careful if you want to futz around with the flexi quiz. But okay, cool. So yeah, one reference locking error just to keep me humble. That was a fun case. It was. I can see Harry said he didn't want to put this in for the MEWC because it's a little different style, and I can see that. I loved it. I I think partly I loved it because I had to stop and think in a way that like I probably wouldn't like it if that happened in an MEWC case, that things were not clearly explained. But here it's just like it's very sort of terse. It's just, this is how check digits work. And then you just have to go and, make it work for yourself. And then the whole theory around, each of these checks together representing which number is off is pretty cool. Yeah, love it. Harry, I hope you make more of these. And more to the point, I guess, I hope lots of people make more. Like, I love the idea of people making cases, not just for the MEWC and on MEWC timetable, but just all the time to share. I think it would be a great direction for things to go in. Anyway, that's all I got for today. Thanks for watching. Harry, thanks for making the case, and I'll see you next time.